So the title of the presentation is about combining machine learning and QCA methods of data analysis. And when we're talking about data analysis, I suppose I should be a bit more specific and say what we're looking at is configurational analysis of the type that people who use QCA are familiar with, but I'll elaborate on that as we go along. Okay, so what is ValC3? It's an Excel application, that is a package of instructions within Excel, which are written in Visual Basic, and basically, you can't see these, they're all hidden behind the scenes. But this Excel application is basically an organized and semi-automated sequence of data management and analysis procedures. That's quite a mouthful. So organized in the sense of there is a workflow, a sequence of steps that you would go through from beginning to end. And you can see that in the form of this workflow chart. And you'll see it's got some feedback loops, meaning that you can return to your early stage and revise how you took that approach. So it's a sequence. It's semi-automated in the sense that quite a lot of the data gets automatically processed and moved along as you go along, but there's a critical points where you make some key decisions, which obviously will affect how the whole process works. So that's in abstract, and what we're going to do today is I'm going to walk you through that. That's going to be a major part of the presentation. And there is a supporting website. This is the address of the supporting website. And I encourage you to have a look at it because it's got an awful lot of information there. But one of the things that is there, which you can see, and I'm going to see whether I can make this work. You'll see over here, 1, 2, 3, 4, 5, 6. These are all the stages in the workflow. And if you click on each of these on the website, there's a drop-down menu, which will give you information on how each of these stages in the workflow work. So that should be useful to you. Also over here, I should mention, there is an email list for sharing of information about ValC3, which I've just recently set up. And the postings of that email list are available on that address there. Right, let me see if I can move this forward. Okay, so the data that ValC3 works with is very simple in its format. We've basically got things called cases, which are presented in the rows. And these are entities of a similar kind. They might be individuals, households, groups, organizations, countries, or locations, or events. And in the columns, we've got things called what I call attributes, but in QCA language, they're called conditions, and in machine learning, they're called features. And these are attributes of the cases. So they might be describing something about the context of the case itself, or something that was done to the case. And this information is stored by column, and in the cells are zeros and ones indicating whether that attribute was present or not in that case. And the example I've got here is from ValC3. There's a built-in example data set, and it's from Crook, who did a study of what are the conditions supporting high levels of women's representation in Parliament in 26 African countries. And so you can see the countries listed down the left-hand side, and across the top are a number of possibly relevant conditions, whether there is proportional voting, whether there are quotas for women, women's level of status in the country, whether it was in a post-conflict situation, etc. So that's the sort of data set that ValC3 works with, and it's basically the same kind of data set as you would see with CRISP-set QCA. So what can ValC3 do in brief? It can identify attributes of an intervention or its context, which are good predictors of the achievement of an outcome of interest. And then it can compare and evaluate the performance of these predictive models, because often there'll be more than one. And it can identify relevant cases for follow-up within case investigations to find out whether there are any causal mechanisms underneath there that are making things happen as they described. Now, I've got this little set diagram on the right where the big circle describes all possible relationships between a data set that we just saw before. And a subset of those are predictive models, where certain of those attributes will be good predictors. And a subset of those predictive models will be causal models. Not all predictive models will have causal mechanisms at work, but a subset may. And a point I want to make here, and I think it's perhaps a little neglected, is that when it comes to evaluation generating useful knowledge, causal or explanatory models are useful, yes, but they're not the only thing. Predictive models are also useful. And I use the simple example of when I walk a couple of meters away from my house here, I walk towards the traffic light, towards the pedestrian lights there, with a confident knowledge that if I wait there for a minute or two, I'll be able to cross safely to the other side of the road, because my prior experience has told me that it only takes about 2 or 3 minutes after I press the button that the lights will change. So that's a predictive model I've got in my head. I don't know very much about the inner workings of the electronics that make that work. I don't know much about the causal process involved there, but I am confident in my predictions. So in that case, a predictive model is quite useful, even though I'm a bit weak on the understanding of any causal mechanisms underneath it. So I just want to reinforce the idea that from a practical point of view, having predictive models and having causal models, both are useful. Predictive models for responding things and causal models for actually causing things, for making things happen. Right, so let's move on to the next one. And because the title of this presentation was about combining machine learning and QCA, I just want to explain what that means a little bit. Machine learning focuses on prediction, and QCA is primarily concerned with causation. And I think we can marry these two perspectives. Machine learning, my simple definition of machine learning is where you combine processes of search, evaluation of search results, and the reiteration of that process until you can get no further improvement in the achievement of a particular objective. And in VLC3, there are 4 different types of search algorithms and 10 different evaluation mechanisms that you can apply to those. And so it's got quite a lot of flexibility in terms of the search processes that you can use. On the other hand, QCA, as I said, addresses causation, and its main characteristics here are, well, I suppose 2 points of note here are that it combines the importance of cross-case analysis with within case analysis. I think that's a really important feature. And it differentiates different types of causes, particularly talking about conjunctural causes, where packages of factors or conditions make a difference. And it talks about necessary causes, sufficient causes, and causal asymmetry, that, you know, when things don't happen, it may be not because of the absence of causes of things happening, but of other factors altogether. Okay, so that's the brief explanation of the title of the presentation, and I'll come on to that a bit more. But what I want to do now is walk you through the workflow, and the first worksheet you'll see when you open up a VLC3 is this Get Started sheet. And the only thing I want to draw your attention to is the checklist to use before inputting data. I'm not going into any detail there, but you really should pay attention to that checklist, because if you don't, it won't work. The next worksheet is called Input Data, and basically what you want to do is copy from an Excel file or wherever else you've got the data set you've got in the kind that I've already described, which is simply rows and columns, where within the rows are all the cases and the columns are all the conditions, including the outcome that you're interested in. And you click on this paste data button over here, and it'll take the data from your clipboard and shove it straight into this part of VLC3. And when you've done that, you then click on Select Data, this next option, and that'll take you to this next stage. It might be that you've got quite a big data set and you've got more than one outcome, or you've got quite a lot of attributes and you don't always want to use all those attributes in a particular analysis. So you can, as in QCA software, you can say, please ignore this column and please treat this one as the outcome, and this one here we'll ignore for the time being. So you can make those decisions by clicking on this row above. You can't see it, but it'll provide you a drop-down menu. I won't go into any more detail about this at the moment, but I want to highlight one important feature here, which is this optimization button. If you click on this and you've got a large number of attributes, it will help you find an optimal set of attributes which both maximize the diversity in your data set, but also minimize the inconsistencies in any of the configurations that you find there, any sets of cases. And that, I think, is a rather unusual feature of a ValC3 compared to both QCA and other similar approaches in machine learning. In machine learning, it's called feature selection or feature optimization. It's not necessary here because it's quite a small data set. So we then go from there to clicking on design and evaluate, and we'll see what happens there. And this is the guts of the center part of the ValC3, and it's got three parts: a design section on the left, an evaluation section in the middle, and an explore section on the right. On the left, it's like a restaurant menu, and it lists the outcome there at the top, and then all the attributes which are in your data set, which might be predictors of the outcome. And you can manually click on these here to indicate 1 or 0 or not applicable. So it's like you can put in your own model that I think, for example, I could click on this to make it a 1 and say, well, that means I think electoral systems, proportional voting electoral systems probably make a difference to the level of women's representation in Parliament. I'm not going to do that now because it's not live in this version. So you can manually sort of create a model here. And as soon as you do that, the Excel will automatically search through and find the number of cases that fit that model that you've just put there. And it'll represent them in this rather unfortunately fuzzy image here. This is called a confusion matrix. And so in the top left corner, it says the number of cases where the model attributes are present and the data says the outcome is also present. So you'll see here, I've already clicked 2 attributes for this model, that quotas are present and the country is in a post-conflict situation. And that's a predictive model of the women's representation in Parliament being at a high level. Well, when Excel searched all the data there, it said actually there are 6 countries with that model attribute and where the outcome is present. And there are no countries where those model attributes are present and the outcome is not present. And it automatically converts that into a statement of sufficiency, that it is sufficient if you have those 2 attributes for the outcome to be present, because there is no cases here where when you've got those attributes, the outcome is not present. I'm rattling on a bit, probably a bit too fast here, but basically you've got a manual model on the left and an automatic summary of how well that model fits the data in this confusion matrix. I won't talk much about this down here, but basically these are all different performance measures of your model based on the figures in this confusion matrix. And in real life, if you click on any of these numbers, you'll see how the formula is constructed. And if you click on the question mark there, it'll explain the formula in words. So on the right-hand side, we've got a different approach. If you click on this, it'll bring up this detailed menu option over here, where you can select from 4 different search algorithms here to get it to automatically find you the best performing model. So you might have done reasonably well over here with finding a model that does quite well. In fact, that model is quite good. It's got an 88% accuracy. What that means is that when you add the true positives and the true negatives, they're 88% of all the cases. So that's quite good. But you might not have done quite so well with your manual hypothesis testing, and you might want the searcher algorithm to find you something better. So you go over here, bring up this menu, and you can choose one of these algorithms, which are search algorithms, which I won't go into detail with. Then down here, you say what performance measure you want to use. And as a default, I encourage people to use the accuracy measure over here, although it's got its problems. And further down here, you can put some constraints on that search, but we won't go into that. So here we have design on the left-hand side, where you can manually construct a model, an evaluation function in the center, which will tell you how good your manually constructed model is, or how good your algorithmic found model, your machine learning model performs, that'll also put the results there. So once you've got a model, and we have one here, you can go up here and give that model a name, and you can save that model. And that's will take us on to the next step. So I've saved here 2 models, and each row is a model, and it's got a lot of detailed information about the performance of that model. And as you go along, the machine learning models will automatically save. The manually generated ones, you have to name them yourselves, but you will accumulate the names of various models down here. Once you've got that, you've got 3 options. By clicking on one of them, you can go over here and click on Evaluate Model. It'll take you back and show you the full details of that model in that screen that we just saw. Or you can click on 2 of them, and if you click on this one up here, it'll show you how those 2 models compare, and I'll take you there in a minute. Or if you click on one model, and then click on View Cases, it'll give you a different perspective, and I'll take you there as well in a minute. So let me move on. So I've clicked on Compare Models, and often in QCA you'll find results which talk about the different models or different solutions, as they're called in QCA, having a raw coverage and a specific coverage, I think it is. But basically, often when you're finding predictive models and solutions in QCA, those models overlap in the coverage of cases that they apply to. And that is, in a sense, that is problematic if you're looking for some causal explanation. They can't both be right. So what we do in EvalC3 is you get this perspective which shows you which particular cases are covered by 2 particular predictive models. Or we could have 3 or 4 models along here, and you can see how they overlap. And so when you move along from this cross-case analysis, which is the dominant focus of EvalC3, to within-case analysis, you already know that, hey, it's going to be worthwhile looking at Namibia and South Africa and Uganda inside those cases to find out whether there's anything in favor of this model rather than that model. So it's giving us a pointer straight away to what we might want to look at when we do within-case analysis, but it's not the only pointer. So I'm now going to go on to the next stage, and I'm mindful of time moving on. So let me go back a few steps. So say I've just selected one model here, and then I click on View Cases, and it's going to bring up that model. And in this case, it shows me all the true, these are all the true positive cases covered by the model, where the model actually fits. The attributes of the model are present and the outcome is present. It shows me all those cases, but it also shows me the true negatives and the false negatives. It shows me all the cases according to which box in the confusion matrix they belong to. But not only that, by clicking up here, it tells me how those cases compare to each other in terms of their overall similarity when you look at all their attributes. So Namibia has got the highest similarity figure of 73%. So if I wanted to do a within case analysis to find out whether any causal mechanisms are going on, you'd want to look at a case that was what you might call modal, something that was in the center, something that was representative, as near as representative of all those cases in that group. So by looking at this percentage figure, 73 here, and selecting Namibia, I'm less likely to find a causal mechanism there that's actually unusual, because I'm focusing on a really average case. On the other hand, I could also select Ethiopia because it's the least similar in the true positive cases. And if I also find the same mechanism working there, I'm getting a bit more confident. Now, I should not be going into too much detail here, but there's one other option here, whereas I can nominate a particular country like Djibouti, click on it, and then click Compare, and it will tell me what other case is most similar and most different. And that has some relevance for case selection strategies as well, but I will not go into that there. So back on the website, there is on this particular page a lot of detailed advice and suggestions about, okay, how to take this within case inquiry process forward and what sort of questions to ask about each of those types of cases. And I haven't listed them here, but you'll find them on the website. Now, in summary, what does EvalC3 offer in addition to QCA and machine learning software? I think the attribute optimization or feature selection or condition selection, which I mentioned at the beginning. That I think is unusual and useful. Quick manual hypothesis testing, I don't think that's readily available elsewhere. The detailed comparison of case coverage of competing good fitting models, I think that is particular to this software. And tools for case selection for follow-up within case inquiries, and a supporting website with a lot of very informative guidance on it. I'm not sure whether I'll just quickly go through here. On the website, it's also got a page suggesting all the different points in time in a project cycle when you could use Eval C3. And I've got 4 examples here of recent uses of Eval C3. Interestingly, most of them with Oxfam. And then I've got 3 example cases here, which I won't go through now because I think it might be an opportunity just to give people a chance to ask questions. And then if we have some more time, I'll come back and talk about these 3 examples. The last point I just want to make was we're now in the process of getting Eval C3 online, which will mean that everybody has the most up-to-date copy. There'll be no problems with incompatible operating systems or versions of Excel, and you'll be able to save stuff online and download it. And I'll be able to track who's using it, how many people are using it, and how well they're using it and what problems they're having. And I'm looking for funding support on that. So if anyone can help with ideas on that, they're much appreciated. Right, so I will stop there and go back probably to here. So Bridget, shall we open up for questions at this point in time?